Here we're going to explain induction. First we're going to show that all of the metal objects here are completely grounded, including the little meter down there. The leaves are just hanging. First we're going to charge up the plastic tube here with some fur. The electrons are transferring from the fur onto the plastic tube. And back over here we have the two globes touching now. So we're going to hold the tube really close to the first globe, not touching it though. And that's going to...
and that because the rubber or plastic tube has a negative charge, it will force the electrons from this globe to this globe, making this have a negative charge and that have a positive charge.
And then we split them apart, so now that this is holding its negative charge and this is holding its positive charge.
Yeah.
And we're going to show that they have opposite charges. We're going to touch the meter to the negative one first, and it should transfer the electrons onto the gold leaf, which are now separate. And we're going to touch it to the positively charged one now, and the gold leaves should close like that. And that shows that these two have opposite charges.
Okay, in this lab we are going to show attraction and repulsion of positively charged protons and the negative charged electrons. When we charge up a rubber tube, we give it electrons, thus giving it a negative charge. Now, what will happen is, if we bring in the rubber tube close to the ball, it'll polarize the ball, which means the electrons of the ball will go away from the electrons of the tube, thus exposing the protons of the ball, which will attract with the electrons of the tube. Now, as you can see that, they come close. Oh, he has to ground it a little quick. Now they come next. Now they've attracted to one another. And I think it just grounded on my finger. No, not too bad. So now, as you can see, we put electrons into the ball. Now, since the electrons here, there are electrons here and more electrons here, the two repel. But if we charge a glass tube, which gives the glass tube a positive charge, the two will attract. Is similar to the way the protons of the ball and the electrons of the tube attract. So, and that's magnetism.
Okay, this is a Van der Graaf generator, and once we turn it on, Tyler's going to touch it and notice what happens to his hair.
I know. Okay, now as we're waiting for this to happen. Okay, it's starting to happen. What's happening is the electrons that are collected on the ball are traveling through Tyler and into his hair. And so in his hair, they're repelling each other. They're trying to find the furthest distance away that they can be from each other. And so by doing that, it's spreading out. It's causing his hair to rise. Okay. And then for our second demonstration with this Van de Graaff, what we're going to do is Tyler's going to act as a reverse lightning rod once he gets there. Wait for it. Okay. What he's doing is he's charging Darren right now, and so what happens is the electrons are transferring over here to Darren and charging him, and so when I go like this, I'm shocked by the charge that is accumulated on him. Okay. Anything else? Or here's another example of that phenomenon.
So in this lab we're using electrical conduction from the rabbit fur and the wool to apply negative charges to both the rubber rods and the balloon. What happens is when you rub the wool or the rabbit fur on anything plastic, glass, or any kind of insulator, it gives up electrons to the insulator that the insulator holds on its surface.
Right.
We will demonstrate when it repels. That wasn't part of our lab.
Why did it attract to the ceiling?
Well, it attracted to the ceiling because it had a negative charge, and it pushed the electrons of the ceiling away from it, creating a positive charge on the side closest to the balloon. And since opposite charges attract, the balloon was attracted to the ceiling.
The balloon popped because I don't know.
Okay, welcome to AP Physics Lab. Woo! Okay, what we have here is a light string and a light conductive ball on the end of the light string that are both neutrally charged. When we rub this insulator tube with the natural fiber, electrons build up on the outside, and when we put the electron built up tube next to the neutral charged light conductive ball, it becomes attracted because the ball becomes polarized with the electrons going away from the other electrons to the other side of the ball, exposing the protons to be attracted to the electrons on the tube.
And when he touches the rod to the ball, the electrons from the rod, some of them transfer to the ball, and they have the same charge then, and they become repelled from each other.
And when we touch the string to ground it, it becomes polarized again with the tube next to it because it returns to its neutral charge.